Hey guys, so yesterday, or possibly day before yesterday, depending on when this comes out, I did a video on the potential life on Venus based on phosphine readings published in Nature Science Journal. And it's fine, it covered all the points, but I feel like there are many of you, like myself, who are interested in a deeper dive into the science behind findings like this. And so today I have a little booklet of notes that I've taken, and I'm just going to cover in depth the science behind the potential life on Venus. So before we get started, I just want to lay out a little bit of background about Venus. As I covered yesterday, the atmosphere is thick and carbon dioxide rich. It's 96% plus carbon dioxide, and that thick atmosphere exerts 90 times the pressure of Earth's atmosphere at the surface, which is the equivalent of being 900 meters underwater. Beyond that, the temperature, once again, we have rampant greenhouse effect from carbon dioxide, and that's given Venus a surface temperature of above 300 degrees Celsius. And that's not even mentioning that sulfuric acid rains on the surface basically constantly. So maybe not a place where you or I would like to live. But if we go higher up into the atmosphere, as with Earth, it's going to get colder. The air pressure is going to decrease. And at this range, around 50 kilometers to 60 kilometers above the Venusian surface, we have this area that temperature ranges between negative 20 to 65 degrees Celsius, and the air pressure is similar to Earth's. So this is a good potential environment for life as we know it. And this has been observed in the past. Actually, there's this weird event that has been noted that ultraviolet light in Venus seems to be being absorbed by something. We have light coming from the sun bouncing off of Venus, basically, and we see this spectrum, but it's missing this broad band of ultraviolet. And this has led some scientists, such as the late, great Carl Sagan, to publish a paper in 1963 saying that maybe there's life in this band which is using that ultraviolet light in order to take energy and produce organic material. So that's Venus in the past. And then we get to more recently this thing with phosphine. Now, phosphine is really rare on Earth, like parts per trillion, but we do find it around certain anaerobic bacteria. And as with many chemicals, it has a unique signature that we can get using photoscopic data. That is, when we take phosphine gas, there's rotational and vibrational energies that light of only very specific wavelengths, when hitting the phosphine molecule, is going to excite it to a more vigorous state. And that state then is going to re-emit that energy as it goes back to the lower energy ground state. That's basically quantum chemistry, well, a facet of it in a nutshell. And so we see a very specific band, a 1.123 millimeter rotational transition band, going from the first excited state to the ground state of phosphine. And we can measure that very accurately. And that was done in June of 2017 using the James Clerk Maxwell telescope. And it gave much higher amounts of phosphine than you would expect, even based on the extreme conditions of Venus. If there was 8 times more volcanic activity than we believe there is, maybe, or extreme lightning strikes or new chemistry that we don't understand. But another thing with having that carbon dioxide rich atmosphere, that's a highly oxidized state of the atmosphere. which is to say there are basically more oxygen molecules than there are hydrogen molecules. And phosphine has the chemical formula of pH3. It has a lot of hydrogen, and it would much rather be phosphoric acid, H3PO4, or other more oxidized states. But instead, it's pH3, this highly, highly reduced state, and it's going to try to rip oxygen from other chemicals, or it'll rip a chloride, or basically this highly oxidized atmosphere should just shred phosphine apart. But instead, the scientists recorded measurements that they calculated to be around the range of 20 parts per billion phosphine. Again, on Earth, we measure atmospheric phosphine in the parts per trillion. That's a 1,000 times increase, give or take. So it's extreme. It's so extreme that they did write a paper on this in 2017, but then they confirmed this data using the ALMA telescopic array. It hurts me to say telescopic array because ALMA is actually an acronym of which the last letter already is array, so we're being a bit redundant, but that's a tangent. In 2019, they used the ALMA to confirm this reading of the spectroscopic data for phosphine, and again, they got the comparative amount of phosphine to be around 20 parts per billion. That's extremely a lot. So that, plus the fact that we have this unknown UV absorption in Venus, is evidence of life. It's not strong evidence. There's other things which either one could be, but the point is that we don't know what they are, and on Earth, it would be reasonable to say, oh yeah, absorption of UV light, high energy light for energy, photosynthesis evolved in a different way. That's something that could happen. And we see microbial life living in droplets of water. Again, reasonable things. We see it in acidic environments. And we have phosphine gas now, which doesn't exist naturally. We can't explain the chemical process in a highly oxidized environment where it should be just being ripped to shards. And maybe this means life on Venus. Not highly complex life, not, if multicellular life, very minimal protozoic, maybe fungal life, but not what we would call animals or plants, probably. Plankton, I guess, is a plant. It would be a photoreceptive plant, photosynthetic plant. It's basically single cellular. So these things could happen. It's not certain by any means, but it's enough that NASA has said that 2 of the next 4 potential Discovery space program could be our candidates looking at Venus. Interesting stuff. I'll keep you updated if there are things to be updated. Last updates were about 2 years apart, and as said, Carl Sagan's paper on the UV absorption was back in 1963. So let's just face it, space discovery, exploration takes time. But I, for one, am always very excited to hear about the potential of alien life. I think that I'm not alone. I hope you enjoyed the video. As always, don't forget to like, comment, and subscribe. And until next time, see ya.